maybe the rest will join along the way, or if not, it's still okay. But Esther has given has an apology. She says she has issues with her internet. So yeah, so we can begin. I hope you can see my screen, and if you
Yeah, yeah, we can see.
yeah, so if you have to react to anything, just speak because I'm not seeing some of the things, but I'll be quick here today so that we get finished on time also and cover as much as possible. So today we said we look at the Docker architecture. So yesterday we looked at a number of things, and yesterday we introduced Docker, and we said what Docker is. We also looked at a number of yeah, we looked at the Docker file, and we basically explained what some of the crucial commands, if I may call them, the contents of a Docker file. And that means from this point going forward, it should be quite easy. And then I said that it was important to look at the architecture because with that understanding of what the architecture is like, then it becomes so easy for you to be able to troubleshoot and even understand how everything works. So today I'll just like go through it. So it Docker is built in it uses the client server architecture, right? So we have a client, so you can say this is the client, and then so with the client, most times you are the client when you're issuing commands, like a command like docker build. You'll issue another command like docker pull. You can issue another command like docker run. So you're basically the client that you want to do something, but then so you have to issue these commands, and these commands have to be acted upon by some server, and that server is in what we call the docker host. So we have the client, and then we have the docker host. So within the docker host we have a number of things. So these commands, all of them will be sent to, so it uses REST API to communicate to the server. So all these commands will be channeled to the docker host. So this is our docker host right here. So within the docker host we have a number of things. So number one, we have what we call the docker daemon. It's not the spiritual demon you know of. Can I don't know, the pen didn't change. So we have the docker daemon, and then we also have the docker daemon is like what's the docker daemon? It's like this is like the server, to simply put it. So most of the times the daemon might be running on your PC locally, or your docker container might be talking to some daemon that is existing remotely somewhere else. So it doesn't have to be locally on your PC. So there are those two options. Most of the times when you're building your apps and stuff, you use the local daemon. And so if you've not started the daemon or the server, most of we call it daemon, but I just substitute the server because it's technically a server. So if you've not started the server, you'll get that most of the times your Docker application, Docker will not run. So when you start trying to run Docker commands like Docker build and Docker pull and stuff like that, when you get an error message like your daemon is not up and stuff like that, so you have to start the server. So in Windows it's so easy to start the daemon, even in Linux. In fact, Docker was built for Linux environment, but nowadays since we also have other platforms that need it, it was extended to Windows. So in Linux it's so easy. You can easily start running the daemon or the server so easily with some few commands. So the daemon controls a number of things. So first of all, so the daemon will control the containers and also the images. And yesterday we discussed, we talked about containers and images. We gave the difference. So an image is just a blueprint that we use to create that from which we create the container, right? And we said the container is like, look at it like, you know, you normally have a normal container. You use a normal container to carry some stuff in it. It can be a container that used to carry fruits or a mix of fruits. So in this case, a Docker container is it's just like that container, but it's like an environment in which you have packaged a number of things like library files and so on and so forth that you use to spin up your application. In fact, within a container, you can spin up a number of applications within one container. So you can have like app 1, yeah, app 2, app 3. You can have a number of applications. So it's just a package of an application or a number of applications. That's what a container is. And then an image is like a blueprint that defines what this container will be like, or what the container will contain. So, and we define the image in the Docker file. So you saw yesterday the Docker file, which defines what our image will look like. So when we do Docker build, we are basically using the image. So we're building an image, or we're basically building a container. So when you do Docker build, you're building an image, and then later on, when we want to run, so we build a container out of that image. Okay, I don't want to get into yesterday's discussion, but simply that's what it is. So it can be an image of based on any number of there are so many. You can build your image based on so many things. Just depends on what you're working on. You can build an image for an OS like Ubuntu. So you can have your image based on Ubuntu. You can have your image based on Python. You can have your image based on Node, and so on and so forth. So it's always good you look at that first line that reads from, because that tells you what your image is based on. Yeah, so that is Docker host. And lastly, you might also want to save your images. The images you build, you want to save them somewhere. So we have what we call a registry. So we'll have a registry here, and within a registry you can have a number of so a registry, a good example of a registry is Docker Hub. That's just a registry. So it can be public or it can be private. So public in the sense that when you publish your images to Docker Hub and you expose them publicly, that means anyone across the world can access your image and can pull your image and use it. If it is private, most of the times in enterprise environment, you get that they don't want people to access their images, so that's just meant for that enterprise environment. So they make it private for their own use. Yeah. So that's a Docker Hub where we simply publish our images and even share the images. So you publish and you share your images if you're sharing with your colleagues within the enterprise, or you're sharing with the rest of the world if it is public. So basically this that is the Docker architecture. So we have the client. I'll summarize everything. So we have a client, Docker client, and with the Docker client, what is common there is we use commands. And so we have commands, a bunch of commands like the ones we saw yesterday, and then it uses also REST API, as I mentioned, to communicate with the Docker daemon or the Docker server. So when a client runs any Docker command on the Docker client terminal, what happens is the client terminal will send the Docker command to some server, or what you call the Docker daemon. Yeah. So the daemon receives that command and then it does something with it based on what the command, based on the type of command that was issued. So that's So and the basic commands therefore that you should know, you've seen here we have docker build. So we have docker build to build the image, docker pull if you want to pull an image. So for example, if you want to pull an image from the registry here, you'll use docker pull. And then we also have, if you want to run that image now into a container, so you will use docker run. So those are some of the basic commands you should know. And then of course we said docker host, and that one provides just an environment to execute and run the applications. So in this case, this is our docker host. It can be your Windows machine, where for as long as you've installed docker there, then you basically have a docker host that runs the docker server. Yeah. Or it can be remote. It can be existing somewhere remotely. So you're talking to some a host that is remotely set up. So in most enterprise environments, you get that you don't set up your own, but you talk to some host. Your host is like a server somewhere. So be ready to encounter such if you're going to work in a development environment in some other company. And then so the host contains whatever we've mentioned: the daemon, the images, the container. There's the other things I've not mentioned. We have you can also have the network and also storage, or what sometimes we refer to as the volumes. So we'll look at this in depth and see how you can configure the networks, because the networks are important, because you might have one container. You need one container to talk to another container somewhere else, and they've been hosted separately in separate environments, but then you want them to share some information, or they depend on each other in one way or the other. So you need to set up the networks and securely ensure that there's a communication between the two. You can even set up VPNs and stuff like that. That's the beauty with this. So then, and then the storage bit is sometimes you might shut down your container, but then you want your data to persist somewhere, and then you want also other containers to access that data. So you might have storage existing locally, and as well you might also create some storage. You might have your storage existing remotely somewhere else. Yeah, so all these containers are fetching data from some storage in some server somewhere, or they're also saving their data into that storage. So the thing is, you can have your storage locally, or you can also have your storage remotely. And that means if it is existing remotely and is being shared, other containers also are consuming from that storage. It means that if a certain container goes down, it doesn't impact the storage at any point. The other containers can still continue consuming or feeding data into that storage. So we'll also look at that. So you can see things are well decoupled, and make life so easy. And when you're doing microservices, then it also makes it so it gives you the essence of using it for microservices. Well, so I think with that you have a clear understanding of what the infrastructure is like. So we'll take time to look at networking and the storage, so that you get to understand. But basically, there's one with networking. There's one default network driver, which you refer to as bridge. We also have what you call host, and that one is used when you don't need network isolation or something of the sort, I think so. There are things like overlay and Mark VLAN and stuff like that, but we look at that. I think that needs some time. For the interest of time, I'll just skip that. With data storage, we have things like data volume, which just provides the ability to
Can you hear
create
me?
persistent storage. Someone has a question?
Hello?
Hello, yes, I can hear you.
Uh, just had a question. Uh,
Yes.
I, I know there are a lot of things we'll be learning when we are doing how we do the real project.
Yes.
But the client said the codes you said, for example, Docker's build.
Yes.
uh, what is the function of that regarding, because in the first like we saw in the last session,
Mm-hmm.
uh, like the first line was from something, so the image is called from somewhere. It's
Mm-hmm.
like importing it, I guess, right?
Mm-hmm.
So what's the point of, can you like explain that?
Okay, so with Docker build, maybe I just now that we understand the architecture the way it is, maybe I'll just take this time also to go through some of those commands. Maybe explain what they do most, my most basic commands.
All right.
Yeah, and then now we'll go and do it practically. I think we'll have enough time for the next 30 minutes. So I'll take like 3 minutes to do this, and then we do it practically now for the next remaining 30 minutes. Salim, would you want to help me with that? At least we have a flavor of the two of us, or you want me to do everything? It's actually the same thing. Maybe you can run the commands and stuff. Is Salim there? Yeah, he still is there.
Yeah, yeah, I'm here. I know I'm here.
Yeah. So you can prepare your whatever you had yesterday, and we can basically run and show them what it is, or I can still use my stuff this other side. And you say, do you have an account with Docker Hub so that you can also publish it there if it's not, or you can just demonstrate, show them how it works.
I think I have
Okay,
an
good,
account with
good.
Docker.
So
I also
prepare
have
prepare that as I'm finishing this other side. As you're listening, you can be setting that one up, and then so that you can move fast too. Okay. Um, yeah, it's nice to have Salim here who also has. Or Danny, you also would want some assignment? I know Danny also done this. Okay. But you contribute actively, or he's not there? He left. Okay. So. Fine. So with the commands, so I'll start with the first command. The very basic command is you can have something like Docker version. So with Docker version, you just want to know the version of Docker that you are running. So that's like the first command, maybe after installing Docker, that you might want to run. And then there is also another command called uh, Docker build, the one Annette just asked. So with Docker build is you want to build a Docker image from a Docker file. So you've created your Docker file, you've defined what your image should look like, the contents of your image and stuff. So now you want to go ahead and build the image. So you use Docker build to build your image, but then it normally has some additional attachments to it, like you do tag T, which T is just used to tag. T is used to tag the Docker image, because at the end of the day you need to tag your image so that okay, I'm trying to let someone in. It's okay. You need to tag your image. Why is it important to tag your image? So that it can be easy. You might be in the process, you might create so many images, but then you want to be able to easily it's like versioning in a way, but then it makes it easy for you to identify your image at a certain point and stuff like that. So it's always a good practice to tag your images. So you give it a unique name. So Docker build, yes, you can just run Docker build, it will build the image, but then you want that image to have a name, so that in case in future you are looking through the images, it becomes so easy for you to identify that particular image at that point in time. So yeah, or for separation reasons. So you might be building an image for front end, another image for back end, another image for for the database maybe, or stuff like that. So you want to easily be able to identify the image for maybe front end for an AI model, and for so on and so forth. So Docker build T, and then you give I'll just put that in anchor tag, so we'll have here an image name. So you don't add this, of course, when you're writing the image. Yeah. And then of course you give it the location. You can give the location here. So if it's if the location is at where we are right now, you can use a dot. But if you have a location, you can just like point it to the location. Yeah. Okay, so that was Docker build. We also have, you might also want to run now the image, and the command is so simple. You can just do docker run. That will run the image. And then you need to give it which image do you want to run, so you can use -d and then you give it the image name. So D is used to create the daemon process for that image. So docker D, so you want each image to run on its own separately, so you use -d to create the daemon process for that image. So you might be running a number of containers at the end of the day. So you want to check the running containers or the running images. Okay, so you'll use docker images. So docker images will give you the running images. And then if you just want to check for the latest running container, the one that is running currently the latest, so you'll use a command like docker ps. It's like the Linux command ps for processes, running processes. You want to check the running processes, but in this case we just want to check for the running docker container. So we'll do docker ps. Since it is the latest, we just do tac l. This one is the latest. If you want to check all the running containers, you can do docker ps tac a, and this one will give you all the running containers. So you can just, your interest might be the latest, only one. You want to check the latest, the one at the top, or you want to check all the running containers, the ones you've been running all along. So you can use docker ps a. And these commands are important because you might be having so many containers running and you might not need all of them. They're just consuming resources for nothing. So you want to shut all of them down and just remain with a few crucial containers. So that's why it might be important for you to check. Yeah, or you want the latest to see if the one that you ran lately is running or not. So you can use docker ps tac l, so to get the latest. You can stop. How do you stop a running container? Most people will have issues there. So what you're going to do is you're going to do docker stop, and then you need to identify the ID of the container. Now when you do docker ps, most of the times you'll get a list of the containers with their IDs, so you can always copy their ID. So you'll see a nice so if you're using docker GUI version, it will give you the IDs of all the running containers. It becomes so easy. But then if you're using these commands on the terminal and you're doing docker ps, you will see the IDs. It will list the IDs of the image name and the containers names and their IDs. They have unique IDs. So that's the unique ID that you'll use here. You say docker stop, and then you give it the ID. So it will stop that container. You might want to stop a container, that's one thing, but what if you want to like delete that image completely? Yeah, you want to do away with it. So you use a command like docker docker rmi, remove image, and then you give it the image name. So this command is rmi, which simply stands for remove image, but also ensure to give it the image name, not the ID, but the image name. So I think that is quite easy. So that is to delete a particular image. What if you want to delete all the images? And that is so easy too. So you still use the docker rmi, but then it comes with some other. So it's rmi, and then okay, so there's normally a $, and then you do docker images q. You can find if there is another way to do this. You can just check it up. So docker images q, the space q. This one will basically remove all the images. So R is used to just delete image forcefully. Yeah. in some Linux you do dash F for force, but in this case it's dash R. So did we even have R? So if you want to remove it forcefully, you can add dash R here or tag R. Yeah. Well, that is to delete images. What if you want to delete all the running containers? So remember, we create containers out of the images. So an image is like a blueprint that we use to create a container. So in this case, we're just deleting like the images. What about the containers? So with the containers, uh, so hey, we use docker rm, not image. So we'll say docker remove, not the image but just rm, and then we give it so since we want to delete all the containers, we'll do almost a similar thing. So it will be docker ps a q. This one will delete, it will list all the containers and delete all of them, quit. And then you might also want to, since a container is just like some sort of environment that you can get into, that's the last command. You might want to enter into a container, right? So you'll do docker exec it container, and then you give it container id, and then bash. So it will give you like a bash environment. It will just it will get into the way you use a bash to communicate with Linux. It's the same thing. So this will execute, it will give you some bash environment for you to be able to interact with the container, list the contents of the container, and so on and so forth. So you can run and you can interact with the container just the way you interact with the Linux based environment or Windows using the command line. So it's a beautiful thing. So these are all the commands. Maybe you might want to know for now. They'll really help you. So I let Salim maybe proceed from there. Let me stop sharing. Salim, are you ready? I took 8 more minutes, sorry. It's supposed to end at 8:30.
Yeah, I'm ready. Let me share. So I'm sharing now. So Sebastian, see, you will tell me the commands. I haven't.
Sure. I have them with me right here.
Uh, so this is yesterday's code. It's still the same. So we have Docker desktop. So this is like the Docker app itself. So this is where we have the images, um, where they come, where and this is where they are actually stored. So you can see I have some over here unused for some time. And yeah, so this is Docker desktop. You can install it on yours also. I think there's also a web version,
Yes,
but I
there is.
usually, yeah. So Sebastian, do you have anything to say about this Docker
Maybe
desktop?
you can just show them. So we can see we have containers. So if you want to see a list of containers, you can see them from there. So right now Salim doesn't have any running containers, but once we run, we'll get back here to check to see if there are any containers. I can see click images. So images, I think that's where we were. Yeah, so you can see it has a bunch of images here. So we will use, I think maybe we'll create a new image, or already have one here. So we'll use one or two images here. We'll run one and then we see. Are you using any volumes by any means? I don't think you are. Is there an image
I
of yours
don't think
that
so.
uses any
No,
volume?
no.
Okay, there isn't. Yeah, so I think those are the most important, and then you can set up your own environments and stuff like that, but that's okay. So you can just, okay, so it's taking us to the Docker Hub, I think.
I'm trying to log in actually. Kumbe I
Okay.
didn't log in.
I think if you also want to log in to your Docker Hub from your command line, for as long as you have your Docker Hub account, you've signed up for one. You just use Docker. It used to be Docker login, right? So you go to your command line, you do Docker login. So and then you'll enter your Docker Hub username and password, and that way you'll have synced everything. So if you push your container, you'll get it published directly to your Docker Hub. And when you go check your Docker Hub, you should be able to see your image, not container image. Well, so that is it. So could you so are you
I can
going to
actually
use?
see
Yes.
some volumes over here, but I don't remember what they were for. But I only remember this one from Minikube when I was trying to test Kubernetes.
Okay, so it's like it also creates its own volume by default
Yeah,
when you create an image. Down there on your for Windows on that on you can see engine running on your left, right? So that
yeah,
is
down here.
the engine is the daemon basically. So if it's not running, you won't be able to run any Docker commands. It will basically frustrate you. So you have to ensure that it is running. You can pause it, you can stop it. So you can do a bunch of things as you can see down there. So basically that tells us that our daemon is up and running, and in Windows it so is once you have this GUI sort of user interface, it's easy to start or stop the daemon. Remember, you don't have to have it running all the time unless your computer is a server that is serving other containers remotely somewhere. Then yeah, okay. So are we going to use the terminal, or how are we going to go about it? So I think we'll go with the terminal and then we'll get back here to check, right?
Yeah, you can use the terminal. So let
Okay,
me just
great.
click
Yeah, so
here.
maybe you can start with the first command. It was Docker version to just see what version of Docker you're running.
Okay, Docker.
Yeah, you can see it's running version 26 and yeah, and so on and so forth. Yeah, there's quite a lot of information in there you might want to check. Well, so the next thing maybe it's can we build our image? Had you build it? We can build a new image, give it a new name and stuff like that. It was for
Yeah,
Finlingo, right? Yeah. So you can
yeah.
give Docker build space T
Docker build space T. Is
uh,
it dash T
dash
or
T, yeah,
just
dash T for the tag name,
dash T?
and then you can give it a tag name. I don't know what tag name you want to give it.
Maybe Finlingo. Just Finlingo frontend.
And you can even give it version 1 or version 2. It doesn't matter, but it's up to you.
V1.
Yeah, V1.
What
Yeah,
version
sometimes you
1?
can use dash v1 or colon v1, whichever way you want it. And then so it's in the same location, right? So
Yeah.
you can space dot to show that it is in the Docker file exists right there. Yeah, if it's existing somewhere else, you can give it the file path. So you can press enter and then let's see what happens. So for as long as for as long as the daemon is running and everything is set, you can see it's already building our image. And if you just check in there, you can see it had to pull like the node, because it started when you look at the Docker file. I don't know if you can take them back to the Docker file while it is still building.
Okay.
Yeah, you can see the
So
very
the Docker.
first line was from node version 18, so it pulled it's building our image based on node 18. So when you go back there, you'll see it is actually following each and every command step by step. So you can go back to the terminal and see what is happening right there. Yeah, so so it's still building, and it loaded Docker ignore and checked what has to be ignored and stuff like that. So quite a number of things going on. Yeah, so if you read through that, there's so you can actually see through the lines, you can see what is happening, and you can actually make some sense. You might not be able to really but I think it is it explains something. So at the point you can see library node.js, so that means it loaded it's building our image based on node.js, and then the very first command. So how many commands do we have? We have like 5 lines of commands if we check. So it's one out of five. If we go back to our Docker file, can you just take us back there? We see what how many lines we have. So we have from, that's the first one. Work directory, the second one. Copy, that's the third thing we want it to do. Run is the fourth, and then we have copy, which is the fifth, and then of course you have expose and cmd. So that's like 1, 2, 3, 4, 5, 6, 7. So I don't
Seven.
know. So when
Mm,
we get back to the terminal, let me see. So you can see
okay.
the first one is from Docker, so that's 1 out of 5. So let's see, it's still at that stage, still building the.
The network is slow, so yeah, that's why
Yeah,
it's,
yeah,
it's
because
taking
it
time.
pulls that from a remote registry. So it has that one doesn't exist local. So it has to pull that node image. It has to build your image based on the node image. So it has to pull that from the remote registry somewhere. Yeah, so that will take some time. Uh,
Yeah, but so as you can see here in the images, they are all of different sizes depending on the base image that you used here.
mm,
So like some are 500 MBs, some 200. This
exactly.
one is very big, 1.9 GB.
Hmm.
So it depends on which image you use. So the smaller, the better. I
Sure.
think so.
Yeah. Um, so and it's also a good practice to tag your images. You can see there's only one image that has been tagged here. Like it's been given like version 2. So it's nice for you to also add tags to your image. Although you can build images without tags, but it's not a good practice. So at the industry level, we expect you to tag your images somehow. Yeah, it makes it easy to just organize stuff and be able to get what you're looking for. Um, so how far are we here? See, it's taking some time. Um, Let me see if I can. I think I had something here. It's not even reached stage 2. I think the first one is normally the most heavy thing, where it pulls the.
Yeah, it's
Yeah,
almost finishing. I can see here.
yeah, yeah. So let's just give it a few minutes.
It's failed. Why?
Oh, okay. So you used the wrong one or stuff. Could you go and check the Node.js
Use an
images?
official Node.js runtime as a parent image.
Yeah, there's an issue with that. Maybe you could check and see. Uh,
Oh, so should I like search for? Wait, they gave me a link up.
Yeah, you can try that and see.
Unauthorized authentication required. Um, Docker.
So in the
But
meantime, maybe yes,
last time I ran it, it worked. So
it worked
that's
okay.
why
Or
I'm.
maybe it's the internet or something.
Yeah, I think my internet is the problem.
Okay.
Because you can, there's 20,
Mm-hmm.
yeah, there's 18 Alpine,
Mm-hmm.
there's 18, there's 18 Bookworm,
Mm-hmm.
yeah, there's a couple.
So can I run? Maybe can I share mine and then we
Yeah,
see?
yeah.
Okay. We can stop sharing. We see if this one will behave. So if I can list the contents of my file, you can see the Docker file actually exists right there. So this is like Windows. So maybe I can for you just see the contents of that file. So you can see it's from Python 3.12, and then the work directory is /app, and then I just want to copy the requirements.txt and then run pip install without no cache the requirements.txt to install all the dependencies. And the next thing I want to do is to copy everything that exists in that folder, parent folder, and then of course expose that image to port 5000 when it's running. Yeah, and then I want to run Python run.py. Yeah, so basically that's what we have. Yeah, for the APIs. So I'll do docker build. So I give it the image name. I can say Lingo API v1. So I'm just building it from right here. Oh, so in Linux I have to use sudo here. That is one of the things that you might really not like. Every other time you have to use sudo. Are you able to see clearly my commands, or it's too small? Let me know.
We can zoom.
Okay, let me see if I can zoom this.
It's fine, and we can zoom, I guess.
Okay, fine. Yeah, so there it is. It's building, and this one should be quite fast. I think the internet's okay. So you can see it's yeah. So it's building my image based on Python 3.12, and it's able to load Docker Ignore, the same thing it was doing. So it's done. Actually, we are done. So if you look at it, you can see well. So it went through a number of steps. From the first one, from docker.io, it pulled Python 3.12 image to build this image, to build our image on based on that. And then it went to the second command, which is a work directory. It created a work directory, named it app, copied everything from I'll call it my local PC, or my local repo, into into app. That is, it started with copying requirements.txt, and then it ran it installed the dependencies based on what was defined in the requirements.txt, and lastly it copied the rest of the existing files and folders in my local let me call it local setup into the app directory, and then of course went ahead to, of course it finished to create the image, and then I think the remaining thing is for us to run the image. So copy was the last one. It doesn't look at it. So let's see. Might be wondering, why does it stop at copy? So we have copy right here, so it doesn't go all the way to expose and command, because these are the commands. These ones will be executed when we do docker run. So when we run, it will do Python. It will look for it will run Python command, and it will also look for the file run.py. So it will run those, and then it will expose our app on port 5000 based on what we had defined in our run.py file. So these two I ignored, because at this point it has everything it needs to create the image. So yeah, so the expose and the cmd, those commands, we need them when we are running the image, not when you're building the image. But in this case, it takes that into consideration. Yeah, so that is it with the build. What about we try now the run. So I'll do docker. So maybe just to check the images that we have, we said we have a command like docker what? Was it docker ps? Someone asking, okay, that's my phone. So we want to run the image, so we want to check the images first. So I don't know how many images. I even forgot the name I gave to my image. So I want to check the images we have. So I'll copy the name. So docker images. I need to use sudo here, but it's not, in Windows you don't have to. So we have a number of images. You can see I have Finlingo API version 1, which is like the one I just did right now 3 minutes ago. And then these other ones I had done them 2 days ago and stuff like that. So this is the latest, and I have given it a tag so it becomes so easy to identify. But if you don't give it a tag, it just gives it will give it a default tag called latest, as you can see. And then we talked of image IDs. You can see each image is given a hash value, yeah, using SHA-1, by the way. So this is unique value, hash value for each image, and that's for integrity reasons and also for easy for identification purposes. Yeah, and the sizes, as Salim mentioned the other time. So this image is quite big. It's like 1.2 GB. Maybe there are things we can learn in future in terms of how we can optimize the images to ensure that the sizes are not that big, but then that's something for another day. So as you can see, time is not really on our side, but I just do docker run, or maybe let's see if there are any running processes first before we run our image. So I can do something like that was docker psl to get the latest running process, or again the sudo thing. Yeah, so this is we have Finlingo backend API, and that should be this one. This one has been running. I created like 2 days ago, and I did not shut it down, so I might want to shut it down right now, but let me leave that. Let me just run the current API, which is Finlingo API. So I can do docker run, then I give it the D for, I want it to run a daemon process, to start a daemon process for this image. So I use the D, then I say Finlingo API. Oh, permission again, I keep forgetting that. That's the bad thing with Linux, but there's a way you can do away with that. But anyways, for now, it is what it is. Unable to find image Finlingo API latest locally, or should have given it like the version number. Now this is where the versions, the tagging gets in. So v1, and I think that should work. Yeah, and that works fine. So that is running. So if I check again for the running processes, we could use docker ps. I want all, so I'll not say the latest, but I could still do the latest. So I see the latest is Finlingo API version 1. Here it is running fine. So if you want to see all, so I can say for all, and you can see all manner of running the images that are running, all the running containers. In this case, you can call them containers because right now they are containers. So we use the image to create the containers. So these are the containers that are running. Yeah. Great. At this point, I think I will stop. Is there anything, Salim, you'd want to add? Maybe I skipped something that is so close to your heart here.
No, I think everything is okay.
Yeah, so we'll continue from there tomorrow, and I think from this stage it should be easier. Maybe to publish it, let's do the publishing tomorrow, and then we see now how you can pull your image from the Docker Hub, and then host it, right? So maybe tomorrow we'll do that. We'll get one image and we'll host it. And what happens is every other time you build a new image, you push it. The pipeline. So what happens is once you've built that, you've established that pipeline, it will always be pulling the latest version of your image and publish that. Yeah, and you can control. You can say, okay, I don't want this version of the image to be published. So you can always have control over that. So you can build a number of images, but then you might decide which one you want to be published to. What do we call it now? I'm running out of gas here. Yeah, which one do you want to be deployed? Yeah, and which one so you can always decide which version you want deployed and which versions you want to hold on to first. Yeah. So but we'll get to that in terms of managing the versions and deployment and so on and so forth. So is there any question from the team, or we call it a day? Hope you liked the session. Esther is someone like Esther here. She's in, out, maybe the internet and stuff, but it's fine. We recorded this session for her, and I think we'll be able to deploy this. So thank you so much, and my co presenter Salim, thanks a lot as usual. So see you next time.